Hi guys, it's me. I can't be here today, so I'm going to give you your lesson notes with this video. We're doing 1.4D. I have no idea why it's called naked math, but I do know why it's called error analysis. So let's go ahead and go through these. You guys should be following along with me in your binders on page 91. Page 91. And everything I write, you write. And if you need to have the teacher pause the video and go back, go ahead and ask. So I'll go through this slowly and make sure that you are able to keep up here. So reading the problem says Austin was trying to solve the equation 4x minus 8 equals 24. We're supposed to look at his work and describe the mistake. So it's telling us he made a mistake. Then solve the equation correctly. So I'm going to actually ask you guys to do the equation with me correctly first. So let's rewrite it over here. And let's go ahead and solve that equation. Now, think of these as algebra tiles. If I have 4x, which is the 4 of the rectangles, and negative 8 tiles, what could I do to get rid of those minus 8 tiles? Now you'd say, well, subtract them. Well, I don't have any negative tiles on this side, so instead of subtracting 8 tiles, what would make them cancel out? And I hope you guys are thinking or saying 0 pairs. So if I have negative 8 tiles here, and if I add 8 tiles, don't those make 0 pairs and cancel out? Of course they do. But whatever I do to one side, I do to the other. So you would write 4x, and those of course cancel each other out, equal. If I had 24 and 8 more, now I have 32. So if I have 4x's and 32 singles here, so if I divide this into 4 groups, and that's actually what I'm doing here, dividing into 4 groups, 1x must represent 32 divided by 4, which is 8. So let's compare what we got to what he got over here. So let's see, he had the same thing to start with, then he divided both sides by 4 and then added 8 to both sides. Well, what did we do? Didn't we actually do the exact same thing except in a different order? So we'll describe his mistake. He should have added 8 and divided by 4, so he should have added 8 first, then divided by 4. So he just did it in the wrong order, and hopefully you recognize that. Okay, question 2. Keely has a bunch of quarters and nickels in her purse. Well, you guys know quarters. I'm going to write this as 25 cents, right? And of course nickels are how much? I hope you guys are saying 5 cents. And be careful with that little 0. That's 5 cents. If you don't put that 0 in there, it's actually not 5 cents. It's 50 cents. So she has a bunch of quarters and nickels, 7 nickels in her purse worth a total of $2.60. Find out the number of quarters. So if we're trying to find out the number of something, we know that there should be an x in there. She wrote this equation, 25x plus 35 equals 2.60. So this is an equation that's trying to represent what she has in her purse. So let's see what mistakes she made. And again, they're telling us there's a mistake, so something's wrong with this. Well, I hope you recognize that the quarters and the nickels are decimals, and here we don't have any decimals. Here we do have a decimal, and here we also still have it. So the mistake is actually that you either have to talk about cents or dollars. This is 25 cents. This is 35 cents, which comes from the 7 nickels. But this is not cents. This is $2.60. So if I want to keep everything in cents, $2.60 is really equal to how many pennies? And if you'd move the decimal over, then you would get the right answer. So let's rewrite the equation to fix the mistake. So if we have 25 cents times some number of quarters plus 35 cents, that's the 7 nickels, it should equal 260 cents. Now we have all cents. Now we can solve the equation pretty easily. Again, how do we cancel out these 35 singles? With negatives. So then I draw my line. These make 0 pairs. Now I'm left with 25x equals 260 divided by, minus 35 is 225. Now again, we're talking about dollars and cents here, in this case just cents, but think about this. If this is 25 cents and this is $2.25, which it really is, how many quarters would it take to make $2.25? And if you should be able to do that division in your head, or just start counting quarters, you should end up with 9. So what mistake did Keeley make when she wrote the equation? She used cents and dollars instead of just cents or dollars. In other words, the decimals were mixed up with non-decimals. Finally, number 3 says write a situation that could be modeled by this equation. So what we'll do is just look at what we have here. We got a big number and we're subtracting 5 times some quantity and ending up with a small number. So how about like we think of this as money? So you start with $1,240 and buy a $5, that's where this comes from, lunch, and the buying part, which is spelled incorrectly here, and you buy, that's this buying, $5 lunch each day. And that's the X. The each day is the X. And then we got to account for the 75. So if you start with $1,240 and you buy a $5 lunch each day, how many days can you buy lunch until you're left with this? With $75. And that's the situation that I made up for this equation. Alright, turn the page to 92. You see that I've written skip, 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 skip on these 4, so you can do the same thing. C, D, E, and G. We're not going to go through. We're only going to do 4 of these equations. So I'll begin at number 5A. It says solve each equation and show all work and verify. So this should be easy for us at this point. You have 15 minuses. To cancel those out, you would add 15 positives. That would make 0 pairs. Would leave you with 8x, nothing here. 41 plus 15 is 56. If I have 8 x's and 56, I could divide it into 8 groups, and I get x equals 56 divided by 8 is 7. And don't forget we want to verify, so we're going to take that 7 and we're going to put it right back up here. 8 times 7 minus 15 should equal 41. And we know that's 56 minus 15. 56 minus 14 does indeed equal 41, so we verified. Okay, letter B. Just like I had minus 15 here, I had to cancel them out by adding 15 to make 0 pairs. Well, what would make 0 pairs for positive 11? Hopefully you're saying negative 11. And whatever you do to one side again, you do to the other. So let me draw a line. Now think of these as algebra tiles. Over here I'm going to draw it very small. Don't I have 16 negative single units? And here I'm adding to that 11 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here those make 0 pairs and I don't have any single units left. But over here I have 16 and 11 more negatives, so I really have a bunch of negatives. So what do I have left over here? Negative 3x. And over here I really have 16 and 11 more negatives, which makes negative 27. If I counted all those, I could get 27, or I just add those two numbers and keep it negative. Now, do you remember when we had the algebra tiles, if I had negative x's on one side and negatives on the other side, if I flipped them both over, they'd become positive. Well, what essentially you're doing is you're dividing out the negative from both sides, and a negative divided by a negative becomes a positive. So now we have to verify the solution. Let's take the original equation, replace the x with the number that we just got, add 11 to it, and we should end up with negative 16. So multiply those. A negative times a positive is a negative. 27 plus 11 equals negative 16. And if I think of these as, zero pairs canceling, if I have 27 and 11, 11 of them are going to cancel out and leave me with, guess how many? Negative 16. Okay, let's move on down to letter F. If this was a balance scale, if you remember that from a few days ago, I would have 6 X's over here, right? 6 big crates. And you obviously know I'm not going to draw 360 little guys here. I have 14 crates over here. So it's almost getting silly, right? When I have these big numbers, the model is kind of hard to do. So rather than thinking of it with a model, let's just realize what we would do. If I have 6 crates here and 14 crates there, wouldn't I just take 6 of them away from both sides? Couldn't I just do that rather than draw it? Well, that's what you're doing. You're going to be left with 360 rocks. 14x minus 6x is 8x plus 288. And again, I don't want to draw this. This is 288. That's a huge number. Well, what would I add to 288 to make 0 pairs? Or what could I do to both sides here? Since I have a bunch of rocks here and more there, couldn't I simply just subtract all 288 rocks from both sides? And that would leave me with just 8 boxes. And over here, 360 minus 288 is 72. Then if I divide them into 8 groups, I get each is worth 9. Okay, quickly verify. I take the 9, I put it up here in the beginning. 6 times 9 plus 360 should equal 14 times 9 plus 288. And if you multiply it out, 6 times 9 is 54 plus 360. 14 times 9, well, that's 131, I believe. 14 times 10 is 140, so this is 131 plus 288. And if you add those together, you should end up with a statement that is true. Well, the beauty of video is that I can go back and correct a mistake. This is 126. And this is 360 plus 54 is 414. So you end up with 414 on this side, and hopefully that would add up too. So 126 plus 288 equals 414. We verified. Okay, last one quickly. All I want you to do is recognize that you're distributing a negative here. So you end up with 56 equals 4 times 139 equals 556. 556. That times that. And a negative times a negative is a positive. And 4 times 5 is 20x, but that's a negative, and that's a positive, so it's a negative. Okay? Here, to get rid of all 556, you would have to add negative 556 little guys. And you'd have to add negative 556 little guys here. That would cancel all those out, and that plus that would actually give me 500 negative left over. And over here, I'd be left with just the negative 20 tiles here. You would divide both sides by negative 20, and you'd end up with x equals 20 goes into 105 times, so 25 is the answer. And my video is about to run out of time, so I cannot verify it, but I assure you it's correct. Thanks, guys.